So this is a lesson about how to prove that lines are parallel. So there are 5 ways that you can prove that 2 lines are parallel. And basically these are the converse of what we learned in the last lesson. We learned that if 2 parallel lines are cut by a transversal, that corresponding angles are congruent. Well, if you can show a pair of corresponding angles are congruent, then you prove that the lines associated with those angles are parallel. You can show that 2 alternate interior angles are congruent to prove lines parallel. You can show that a pair of same side interior angles are supplementary. You can prove that both lines are perpendicular to a third line. That would make them parallel. And then you can prove that both lines are parallel to a third line. That's another way that you could prove that 2 lines are parallel, if they're both parallel to the same third line. So let's investigate each of these a little further. Okay, so in my first example I have pairs of intersecting lines, L and M intersecting, each of those intersecting both A and B. And so I've got various angles numbered. So for the first example, let's say that we have information that angle 1 is congruent to angle 2. So angle 1 congruent to angle 2. So what you want to do is trace each of those angles. So I trace angle 1 and I trace angle 2. The line that you touch twice, if there is one, is the transversal. So if I connect along that transversal, line L is the transversal between angle 1 and 2. The other side that's not the transversal of angle 1 and the other side of angle 2 must be the 2 parallel lines. So if angle 1 is congruent to angle 2, then because of corresponding angles being congruent, those would be corresponding angles congruent, then I know that line A is parallel to line B. So for a second example, let's say I have information, or it's given, that angle 3 is congruent to angle 4. So I look at angle 3 and I look at angle 4, and I'm told that they're congruent. So I'm going to trace angle 3 and trace angle 4. The line that I touched twice was the transversal between them, so I'm going to connect that line. And then what this tells me is that the other side of angle 3 and the other side of angle 4 must be parallel. So if 3 is congruent to 4, because those are alternate interior angles that are congruent, that tells me that lines L and M are parallel to each other. Okay, so for a third example, let's say I'm given, or I have information somehow, that angle 5 and angle 3 have a sum of 180 degrees. So angle 5 and angle 3 are supplementary. If I trace angle 5 and I trace angle 3, the line I touched twice, which in this case was L, is the transversal between them. The other side of angle 5 and the other side of angle 3 are going to be the 2 lines that are parallel. So because same side interior angles are supplementary, I have the lines A and B being parallel. And that's just a little technique of tracing angles. The line that you touch twice is the transversal. The other side of the touched angles, the other 2 sides of each angle, are the parallel lines. Okay, and then the last ways to prove 2 lines are parallel is if they're both perpendicular to the same line. So if I have in the upper diagram here line L and line M intersected by line T, and it's given that L is perpendicular to T and M is also perpendicular to T. So then I know that L and M, if both perpendicular to the same line, must be parallel to each other. Okay, and then in the second example, if two lines are both parallel to the same line. So I've got a blue line, a purple line, and a red line. And if it's given to me that blue is parallel to the purple line, so blue is parallel to the purple line, and then red is also parallel to the purple line, I know, it's kind of like transitive property, that blue and red must be parallel to each other. And then there's one more little property, or two more that are in this lesson that we might as well cover now. It's kind of random. But the property is that through a point outside of a line, there is one and only one line that is exactly parallel to the given point, to the given line, that goes through that point. So that red line is the one and only one line that's exactly parallel to the black line that passes through that one point. And also, there is only one line that exists that goes through that point that's exactly perpendicular to the black line. So only one line that goes through that point that's exactly perpendicular to the given black line. So the way that's said is that through a point outside of a line, there is one and only one parallel line that passes through the point to the parallel to the given line, and one and only one line perpendicular to the given line that passes through that point. And that's it.